Good morning. Here today I have come with this topic. You can see the topic. Okay. The topic is this: gravitational slingshot maneuver. Gravitational slingshot maneuver. So the term gravity is there. Gravitational comes from gravity. Slingshot, this is an effect. So you know what is slingshot? To throw a particle or a piece of stone to a distance, we know rubber bands can easily be used. You fold the rubber band and just in the middle you put the stone and then stretch the rubber band. Okay, just holding the stone with the rubber band, you stretch the rubber band just like this, stretch the rubber band, and when you release, stone goes in the forward direction. That thing is known to you. What happens whenever you are stretching the rubber band along with the stone? Due to stretching, potential energy is stored in the rubber band. Okay, and whenever you are releasing the rubber band as well as the stone, that potential energy gets converted into kinetic energy, and due to that kinetic energy, the stone goes in the forward direction with some velocity. Okay, so that thing is called slingshot, right? Slingshot. So here the term which is being used, the topic is here gravitational slingshot maneuver. So in that case, in the rubber band and stone, you have seen that a rubber band was pushing the stone. Okay, so energy of the rubber band was used, and here in this case, the energy of the planet above which the spacecraft, we are talking about here spacecraft or rocket. Okay, here we are talking about spacecraft or rocket. Say a rocket needs to be launched, okay, and the rocket needs acceleration or deceleration. Deceleration means retardation. That is known to you. So what is the aim of this technique, gravitational slingshot maneuver? Without using extra fuel, say the rocket is moving at a certain speed, it has a certain velocity. Now our target is to save fuel. If you want to accelerate the velocity or the motion of the rocket, what you need to do? You have to consume extra fuel. You have to burn extra fuel for the acceleration of the rocket. And if you want to retard if you want to decelerate, means if you want to slow down, okay, in that case what is required? In that case also extra fuel is required, because for slowing down of the motion of rockets, fuels are expelled from the forward direction of the rocket. That way speed or the velocity of the rockets are increased or decreased. When the fuel, means the exhaust of the fuel is leaving from the rear end of the rocket, then the velocity of the rocket increases in the forward direction. But whenever you are trying to slow down the velocity of the rocket, in that case from the forward direction you have to expel the exhaust gas. Okay, so if you want to save your fuel, so in both the cases, whether speeding up or slowing down, in both the cases what is the requirement? A requirement is to burn extra fuel. So if you want to save that extra fuel, what you need to do? You have to take the help of the gravity of nearby planet. Okay, we know that our planet Earth is moving in a certain direction around the sun. If rocket needs to be accelerated, then in that case, what you need to do is that rocket should move in the same direction as Earth moves around the sun. If this be the case, if this happens, then there will be acceleration of the rocket. And if the rocket moves in the opposite direction of the Earth means what? You know that Earth is moving in a certain direction around the sun. So if rocket moves in the opposite direction of the Earth, in that case there will be deceleration of the rocket. Okay, so without consuming extra fuel, both acceleration and retardation can be achieved. Okay, so purpose is what? Without using extra fuel, you need to either accelerate or decelerate the motion of the rocket or spacecraft. Okay, and for that purpose this technique is used. Okay, you have already heard the name of a spacecraft, Voyager. Voyager took help of this effect of so many planets. In our solar system there are so many planets, you know. Okay, so to move in the solar system, the spacecraft Voyager took the help of this effect, okay, took the advantage of this effect from so many planets. Okay, okay. This is the end of this lecture. Okay, this is the end of this lecture. So, no, sorry, this is not the end. This cannot be the end. What principle of physics is being used here in this case for this effect? What principle? It is conservation of momentum. Conservation of momentum, this principle was used to get this effect. Say you are moving inside a train. The train is moving in a certain direction and in the same direction. Say you are inside the train. You are staying inside the train and you are moving in the same direction of the train. Okay. So for an outside observer who is standing on the surface of the earth, for that person, what is happening? Whenever you are moving inside the train in the direction of the train itself, then your velocity increases. Okay, and if you move inside the train in the opposite direction of the train, in that case, for an outside observer, your velocity decreases. Okay, your velocity decreases with respect to the train. If you are sitting inside the train, with respect to the train, you have zero momentum, you have and zero velocity. But for the outside observer, your velocity will be equal to the velocity of the train itself, right? And if you are not sitting inside the train, you are moving inside the train, either in the direction of the motion of the train or in the opposite direction of the motion of the train. In that case, there will be change in velocity. Okay, the same thing is happening here for the spacecraft and the planet. Okay, so ultimately what I want to say is that here for the combination spacecraft and the planet, okay, conservation of momentum, that principle was used, and following that principle, really in real life rockets move in space, not spaces, in space. Okay, now this is the end of this lecture. Thank you for watching this video.